Hello everyone, a video on the cooling modification on this HP 840 G5 laptop. First thing first, I'm working on the back of the motherboard in the area where the keyboard stays here. So here's the metal frame, the metal internal chassis, I would say, the backbone of the machine, and I use this surface, this metal surface between the motherboard and the keyboard to absorb and dissipate the heat. In order to do that, I'm using a lot of thermal pad squares, small squares, in order for them to press down and adapt to the different sizes, the different shapes that are here, and this should give a very good thermal distribution. On this top area here where the VRM are, sadly we have plastics. Get the pads like this, but we're gonna do that anyway, so we done it anyways. And now between the structure and the keyboard and the thermal pads, the thick one here, I removed the plastic and all the glue that was on this the little nipple in the middle of the keyboard, and it's gonna be touching here this area, so it's gonna take a lot of heat from the main board on this metal piece, I guess, and then all this area that is the hottest one behind the processor CPU is gonna spread on the keyboard. Getting ready for reassembly. Thermal pads on the side here and PTM 7950 on the core. I'm gonna put some thermal paste on the PCH here, and I'm gonna dump some heat on the way on the PCB in the empty areas. Start our first Cinebench R15 run and without any undervolting going on. So we're currently sitting at our maximum 41 power. That's interesting. We got to 41 power limit. We're now sitting at 17, 18, something like that. So the power limit are 44 and 18 respectively. So this is what is shown here. And we'll see at the score. We got to 80 degrees, 515. Now undervolt, 120 on the cache, 90 on the unslice, 75 on the system agent. We'll see what happens here. The BIOS version is 1.08. That's the last one that supports undervolt, and we had to manually flash with the external programmer to get this version on this machine. We peaked at 33 watts apparently, so that's a lot less than previously reported. What was that? 41 peak before. And now it's gonna go back to 18, where we're currently keeping at 27 multiplier, 79 degrees maximum. Keep in mind that the system is getting hotter the more we use it, so we are eating into our thermal budget, I would say, that we had from the cold start. That's 608 points, so that's a good 20% more with the undervolting. Okay, it doesn't seem to be possible to edit this number, so the long power limit, sorry, but maybe we can increase the turbo power limit to an indefinite value. Let's see if that works. Let's try this, see if it still falls back to the 18 watt limit. That seems to be working just fine, as we peaked 84 degrees now with 34 watts. As the temperature increases, the package power will increase. That's not normal. Any CPU will behave like that. The higher the temperature, the more power it will use. And that's 720 points. That's pretty nice. Before all this modification, I was getting 440 without the undervolt. I'm not going to run Geekbench because I don't want the machine to update to the latest BIOS. Okay, so we've been playing for hours, watching YouTube videos, listening to music. These are the settings on macOS. The power limit is unlocked with an SSDT from Instantly Mac Forum, and yeah, it's working fine, working very fine on macOS. Dual screens, everything, amazing. Here I can run Geekbench, even though usually the scores are much lower on macOS than Windows. And here's the score with a 28 watt TDP. Let's compare to the similar CPU. Oh, yeah, there's no result for that. That's sad. But maybe a sync machine, which has like slightly better CPU with more cache. Yeah, we're doing good. And I guess this is all for the video. Ciao!